Good evening, ladies and gentlemen. This is your well-rounded math teacher, Mr. Bakar. And we're going to work on today solving quadratic equations by factoring. But first, a little review of solving quadratic equations by graphing, factoring. We'll get to factoring in a minute. Anyway, we're going to graph this, x squared minus 2x minus 3. We're going to set that equal to y, but y is equal to 0. And the reason that is whenever we graph this, wherever it crosses the x-axis, being y is equal to 0, our solutions are going to be where it crosses the x-axis. And we talked about that in 4.2, so you can go back to that and look at it if you need to. So what do we know here? ax squared plus bx plus c. If it's in that form, what's my a? My a is this 1 right here, so a equals 1. That means it's going to open up because it's positive. B is equal to -2, and C is equal to -3. Now, if I plugged in 0 for the x squared and the x, that means they would cancel out, and all I'd be left with is -3. So my y-intercept is 0, -3. We'll use that in a little bit. To find our vertex and our axis of symmetry, x equals, we're going to use that formula, x equals -b all over 2a. -b means the opposite of b, so if b is -2, I'm going to put 2 in there. 2 times a is 1, so that's 2 over 2, or 1. So my axis of symmetry, we can go over here and just kind of put a dotted vertical line here at x equals 1. And that's my AOS axis of symmetry. Okay. That also means my x value of my vertex is 1. Well, we got to find our y, so we're going to plug that in to that equation up there for x. Plug in 1 for x. So y equals x squared. Well, that's going to be 1 squared minus 2 times 1 minus 3. 1 squared is 1. -2 times 1 is -2 minus 3. So that's basically 1 minus 5 or -4. Okay. So 1, -4 is this point right here. Now, usually when we graph these, we make a little table and start out with our vertex. That's 1, -4. And from that point, working towards the y-axis, I'll probably plug in 0 and -1. I already know when I plug in 0, I get -3. So that's this point right here. Now that's 1 unit away from the axis symmetry, so I flip it over and get 1 unit past it right there. So I got those 2 points. I always mirror over the axis of symmetry. And now I'm going to plug in -1. So I'll just put a -1 right here and right here. And figure out what that's going to be. Well, I lost this now. Okay. So plug in a -1 here and a -1 here. Well, -1 squared is still 1. -2 times -1 is positive 2 minus 3. That's 3 minus 3 or 0. Well, -1, 0 is right there. Well, that's where the graph crosses the x-axis. So that's going to be my first 0, x equals -1. The other one, because there's always 2, because it's an x squared term, that's 2 units away from the axis symmetry, go 2 units past it. There it is right there at 3. So x equals -1 and x equals 3 are my zeros. Zeros are the same thing as solutions. So when I solve this, find the solutions, that's the same as zeros. That's why they have zeros there. Or even if they had roots. Roots, zeros, and solutions are the same thing. Just kind of graphing that in there. Okay. That didn't work out very well. Let's try that again. Sometimes if you hold it in here, there we go. Pretty good. I'll go with that. Good enough. Here's my parabola. And my zeros are where it crosses the x-axis once again. That's one way you could do it. You could do it by graphing your parabola. Other than that, graphing is not the only way that to solve quadratic equations, we can also solve them by factoring. When factoring to solve a quadratic equation, you can use the following property, which is the zero product property. It's just stating right here, if you have any real numbers a and b, and that's equal to 0, what has to be true? Well, that's A times B, basically. So A has to equal 0 or B has to equal 0. And that's going to help us solve these quadratic equations, because when we factor them down to, like, say we got a factor of x plus 5 and x minus 7, this is kind of like my A times B, and that's equal to 0. Well, that means x plus 5 could equal 0, and then you just solve that to find your equation. Subtracting 5 from both sides, x equals -5. Or the B, that would be the x minus 7, the second factor. That could equal 0. Solving that, I get x equals 7. Okay, so my solutions would be -5 and 7 for this one. Let's get into one of these and solve it. Okay, there's some steps. Number one, step 1, get everything on one, get all terms on one side. Equal to 0. Can't use zero product property unless you have all your terms on one side. I could subtract x squared, negative x squared from both sides, but I don't want to do that because I want to keep my higher power, my x squared term, positive. So I would subtract 6x from both sides to get all my terms on one side. X squared minus 6x equals 0. Now this is not a general trinomial. There's not 3 terms here, just 2 terms. And so I can either do difference of squares or greatest common factor. Well, they both have an x. I could take an x out of both of them. So that's going to be my greatest common factor of x. X squared divided by x, that's going to give me x right here. Here I'd get minus 6, and that equals 0. So checking your work, x times x is x squared, that's good, and x times negative 6 is negative 6x, so it's factored correctly. Go back here, just so we got the original function. So now, well, that was step 2, factor, and we just did that. We factored it. Step 3 is the zero product property. We're going to apply this now. This is kind of like my A. This is kind of like my B. A times B equals 0. Either A equals 0 or B equals 0. So you take your 2 factors. The first one is just x. X equals 0. Well, that's already solved, so that's one of my solutions, I guess. X minus 6 is the other one. You set that equal to 0. Add 6 to both sides, and I get x equals 6. So x equals 0. X equals 0 and x equals 6 are my 2 solutions for this quadratic equation. Okay, just greatest common factor for that one. For this one, okay, I want to keep my x squared term positive, so I'm just going to leave this alone. I'm going to subtract 5x from both sides and 14 from both sides. To do that first step, get everything equal to 0. So this is going to be x squared minus 5x minus 14 equals 0. I'm just bringing those over to the other side. Okay, so factoring this now. This is a general trinomial, ax squared plus bx plus c. So I'm going to take a, which is 1, and multiply it by b. That's a times c, sorry. That's going to give me negative 14, so I can kind of do that little x method here. Negative 14, they have to add up to negative 5. Well, I'm going to multiply them and get negative 14, so one of them has to be negative. So your only choices are 1 and 14 and 2 and 7. The larger one has to be negative. 1 and negative 14 is negative 13. I'm going to use 2 and negative 7, so that becomes 2x and negative 7x. We could do grouping. You could do, if you like grouping, you can do grouping now. I'm just going to do box method because it seems most of you like the box method. And I'm going to take these 2 terms. But first, I'm going to take my first term, which is x squared, and my last term, which is negative 14 from the original one, and then just plug 2x in and negative 7x here. These 2, doesn't matter where you put them, just kitty corner from each other. Okay, top row, looks like x squared and negative 7x, I can take an x out of both of those, greatest common factor. Down here, 2 and 14 are both divisible by 2. So my first factor looks like it's going to be x plus 2. Going up and down now, the x squared and 2x. X, well, and these two right here, x times x, give me the x squared, so that's working out. That works out there. Both negative, and they're both divisible by 7. I'll go minus 7. So factoring this, I get x plus 2 and x minus 7, and that equals 0. So the third step is ZPP. Okay, we factored it. Everything equals 0, factored it. Now we got to use the zero product property here. And that's where you take your factors, x plus 2, and set each one of those equal to 0. So solving this, I would subtract 2 from both sides, x equals negative 2. Done. Solving this, I would add 7 to both sides, x equals 7. There we go. Negative 2 and 7 are my solutions. And it should have 2 because it's an x squared term. That's my highest power. If I had an x cubed and whatever equals, I'd have 3 solutions, just so we kind of know, okay? Okay, let's do another one here. General trinomial once again, so I'm going to do 1a, a times c, times 64. 1 times 64 is 64. So the little box method, this would be 64. Well, how do I multiply something to get 64 but add it together to get negative 16? Well, they both have to be negative. And I know 8 times 8 is 64, so it's going to be negative 8 and negative 8. X and X. I'll do grouping on this one. No, I'm going to do box. I want to show you something in box. What do we got here? So my first term is x squared, and my last term is 64, and then throw in your negative 8x's. Okay, so going across, looks like they both have an x. And I'm going to put an x here because x times x is this x squared right here, so that should work out. The bottom row, you'd think it'd just be 8, right? But this x times this 8 is not going to give me negative 8x, so I have to make this a negative 8. So most of the time, when these two are both negative right here, you're probably going to have your second terms in both of them are going to be negative also. So like right here, you'd think 64, negative 8x going up and down. This would be negative or positive 8. But when I multiply this x times x, I get x squared, and this x times 8, I need to get negative 8x. So yeah, I'm going to change this to a negative 8. So both my factors are x minus 8 right here, and that equals 0. So I'm on my last step, step 3, ZPP, the zero product property. That's where you take both factors and set them equal to 0 and solve. Both my answers are going to be the same. You don't have to list them out twice. I'm just going to add 8 to both sides, x equals 8. Same thing here, I'm going to get x equals 8. So I guess you could just say it's a double root, obviously, because both the answers are the same. But it's, your answers are both 8. What I would want you to do, hit pause and try this one. And then if you get stuck, then you can hit play again. But try and finish it, hit play. And if you do make mistakes, see where you made your mistakes. Okay, hit pause. And I'm going to solve this. So I'm going to subtract. I got to get everything equal to 0. Okay, hold on here. So I'm going to subtract 9x from both sides because I want to keep my x squared term positive. 3x squared minus 9x equals 0. Greatest common factor here. It looks like both of these I can take an x out and a 3. So 3x is my greatest common factor, so that goes on the outside. Here the 3's cancel out. X squared over x is just x. Here the x's cancel out. Negative 9 divided by 3 is negative 3. So there it is. It's factored. If you distribute this back through to check your work, 3x times x is 3x squared. Good. 3x times negative 3 is negative 9x. So yes, that's factored correctly. And now we can just kick in our third step, Set everything equal to 0, that's the first step. Factoring, that's the second step. Equal to 0, okay? And then ZPP, zero product property. My first factor is just 3x. When I set that equal to 0, some people kind of get freaked out about that. Just divide by 3. X equals, well, 0 divided by 3 is 0. So usually when it's one term like this, you're going to get 0. X minus 3 equals 0. That's your B. That's your second factor. Add 3. X equals 3. X equals 3. So there we are. 0 and 3 are my two answers for this one. Hopefully you got that. If you didn't, hopefully you figured out where you made a mistake. Okay. First step, everything equal to 0. Okay, and to do that, first step. Anyway, I'm going to keep this term positive. The x squared term is always positive. 6x squared is positive, so I'm going to subtract 1. Add x to the other side, so I get 6x squared plus x minus 1 equals 0. It says a general trinomial, so it's going to be a times c. Multiply these two terms, and that's going to give me negative 6. So I got negative 6 here. They have to add up to the x term. That's 1. So 1 and 6 aren't going to work, but 2 and 3 do work. But I think I'm going to make it negative 2 times 3 is negative 6 up top here. When I add them, I get positive 1. So negative 2x and 3x. Good. Okay. So doing the little box method, once again, if you like grouping, do grouping. First term, 6x squared. Last term, negative 1. And then throw these two terms in the other ones. I'll put the negative 2 here this time. And 3x. So top row, going across here. 6x squared, negative 2x. They're both even, so I'll take a 2 out and an x. Here, nothing's in common, so I'm just going to take out a 1. Well, 2x times what will give me 6x squared? Well, that's 3x. And that looks like, if you look at 3x and 6x squared, 3x is the greatest common factor. Here I'm going to take out a negative because they're both negative, and it looks like just negative 1. So 2x plus 1, 3x minus 1 equals 0. So there it's factored. That was the second step. Factor. Okay, third step, ZPP. So I'm just going to set both these equal to 0 and solve. Now, some people think my answers might be negative 1 and 1, but when you take 2x plus 1 and set it equal to 0, you do subtract 1, but you also have to divide by 2, and a lot of people forget that. So my first answer is going to be x equals negative 1/2. You can write decimals too if you want, doesn't really matter. And then 3x minus 1 equals 0. So add 1. 3x equals 1, divide by 3, x equals 1/3. Okay. If you get stuck on this, you can slow it down, watch it again, or come in and ask me questions the next day. Not a big deal, okay? This one, two terms, so it's not a general trinomial. X squared and 25 have nothing in common except for 25 is a perfect square. So is x squared. 5 times 5 is 25. And x times x is x squared. So they're both perfect squares. So it's real simple. What do you multiply to get x squared? X and x. What do you multiply to get 25? Actually, negative 25 plus 5 and minus 5. That's how you factor difference of perfect squares. And then last step is just ZPP. Okay, so I'm going to set x plus 5, first factor equal to 0, and x minus 5, the last factor, equal to 0, and then solve. Subtract 5, x equals negative 5. Add 5, x equals positive 5. Let's write that a little better. Negative 5. There we go. So those are my two answers. And I should have two because, once again, it's an x squared term. Okay. For these ones, we're going to kind of work backwards here. If you look at this, write a quadratic equation in standard form with the given roots. So ax squared plus bx plus c equals 0. We want to go from this, the roots, to this quadratic equation. So basically, we're going to work backwards. Like these are my roots or my solutions, and this is the quadratic equation it came from. Just like these are my roots, my solutions. And I want to go back and write the equation that they came from. Well, you got to kind of work backwards. Like when you look at that x equals negative 5, well, what factor did it come from? It came from x plus 5, because if you set that equals 0, you'd subtract 5 from both sides. So I'd take that x plus 5, and, well, x equals 5, that comes from x minus 5, and then I would just FOIL these, or distributive property twice, whatever you want to call it, and multiply that to get the original function. So let's look at this one. I start off with this, x equals negative 5 and x equals 7. Those are my roots or my solutions. Well, what factors did they each come from? Well, here it would come from x plus 5. That's the opposite of negative 5, okay? Real quick, if this was equal to 0, you'd subtract 5 from both sides. X equals negative 5. That's where it's coming from. So that's that, x plus 5. X equals 7, that would come from x minus 7. And basically, you just take these two roots and multiply them. Set them equal to 0 and just multiply it. Distributive property, or twice, or FOIL. So first, x times x is x squared. Outside, that's just distributing that x. X times negative 7 is negative 7x. And then first, outside, inside, and last, it's just distributive property twice. Distribute the x, distribute the 5 through this quantity over here, and that's FOIL, same thing. So that's plus 5x, x times 5, and then 5 times negative 7 is negative 35. Just got to remember that these two terms in the middle here are like terms, so I'm going to add those together. X squared minus 2x minus 35 equals 0. And there we go. Okay. Next one with fractions, it's a little harder. Not necessarily harder, but a lot of kids look at it a little bit differently. So x equals negative 1/3 and x equals 4. Now this one's easy. That's just comes from x minus 4, that factor. Here, I don't just say x plus 1/3. I got to get rid of the fraction, so I'm going to multiply both sides by 3 to cancel out that denominator. And that's going to be 3x equals negative 1. And then just add that 1 over to the other side. And my other factor then is going to be 3x plus 1. And that is equal to 0 right there. If you break these down, that'd be 0. So what do we, and these are both equal to 0, right? So just take them, the two factors that you have now, and FOIL them, okay? 3x times x, that's 3x squared. 3x times negative 4, that's negative 12x. And then distribute the 1 through the quantity. So that's 1x and negative 4. 1 times negative 4 is negative 4. Combine these like terms. 3x squared, negative 12, and 1 is negative 11x minus 4, and just set it equal to 0. There it is. There's the quadratic equation that it came from. This one, some people think this is, they don't really know what to do with it. Well, they give you the zeros. It's where it crosses the x-axis. So the first one is x equals 0, and this one is x equals 4. So take your roots or your solutions and write them as factors. Well, this one's easy. That's x minus 4. That's my factor there. Here, x equals 0, that's just x. So you're just basically multiplying by x. So x times x is x squared, and x times negative 4 is negative 4x. And that's all equal to 0. There you go. Okay. Let's try one of these. A parallelogram. The height of a parallelogram is 4 more than its base. If the area of the parallelogram is 221 millimeters squared, find its base and find its height. Okay, so just draw a little picture. Here's your little parallelogram. Okay, this vertical or this perpendicular distance down is the height, and here's the base. So they say this. I'm just going to work with x's though. The height of the parallelogram is 4 more than the base. So I'm just going to say this. The base itself is x. Then the height is 4 more than the base. Well, that's going to be x plus 4. Now, area of a parallelogram is just this. Area P, area of a parallelogram, is base times height. That's it. So if I take my area, which is 221, and then take the base, which is x, times the height, which is x plus 4, I just need to solve this. This isn't equal to 0, so I can't use the ZPP. I have to distribute here and solve this. 221, and then that's x squared plus 4x, and then get everything on one side, and then I can actually factor it and solve. Okay, what do we got here? Subtracting 221 from both sides. Because it is a quadratic, there's an x squared, so get everything equal to 0. That's the first step. 0 equals x squared plus 4x minus 221. Okay, so we're going to do the little x thing. 1 times negative 21, well, that's negative 221, and it has to add up to 4. Oh boy, some values. 1 and 221. Okay, that's not going to work. Okay, what else goes into 221? Let me grab my little calculator here. 2 doesn't go in there, 3 doesn't go in there, 4, 5, it doesn't, I don't think. 221 divided by, how about 7? Nope. 221 divided by 9. Nope. 221, not 10, how about 11? Nope. 221 divided by, oh, 12 doesn't go in there. 13. Okay, there it is. 13 times 17. I want positive 4, so I'm going to make that negative 13. So that's negative 13x and 17x. So 13 and 17 both go into 221, so keep that in mind when we get over here. Now we got to do the little box method. X squared and negative 221. You got negative 13x and 17x. Okay, so doing my box and factoring this, got an x here. Guess what? X here, x times x is x squared. These are both negative. They're both divisible by negative 13, so that's negative 13x. Both divisible by 17, so this is going to be, well, not x. Sorry about that. Just 13, okay? And these are both divisible by 17. So x plus 17 and x minus 13 are my factors. And they equal 0. Let's bring this up over here. Okay. So now the last thing you do is use zero product property and just set them equal 0 and solve. X plus 17 equals 0 and x minus 13 equals 0. Okay, here I get negative 17. You know what? You can't have a distance of negative 17, so that's not going to work. Here I add 13, x equals 13. That's true, that'll work. So if I go back to my picture, my base is 13, okay? And then 13 plus 4, that's going to give me 17 for my height. So it says find the base and height. Well, the base We just said that. That's the base. And this is the height. And there you go. We're good to go. If you want help with that last problem, let me know. I can go over it with you.